Next we come down to multi-dimension arrays. The multi-dimension arrays, they are implemented as a number of single dimension arrays. So again we have two ways. We'll just statically declare a multi-dimension array. Same way, the type of the array, we say the name reference to the array, the dimensions, suppose it is a two-dimension array, then we have the operator to assign memory, then we say int, then we have rows, and then we have columns. So here we say what is the number of rows that we have in this array. Suppose we say 4, then we say how many columns do we have in this array, we say 3. So it is essentially a 4 rows and 3 columns array. So we can just generalize this to be 1 1 1 2 2 2. So this is a sort of array that we have generated. It has 4 rows and every row has 3 columns. Just put down. So this is the general way to statically declare two-dimensional array. We have every row, the number of rows, and then we have the number of columns. So in this case we have a uniform column arrangement, that all rows will have same number of columns. So as soon as we initialize such an array, all members are initialized to the default value, as in case of a one-dimensional array. We can print down any index. Suppose I say AR first row second column. I'll just print out this value, that is 0. So every value in this array has now initialized itself to 0. Now to print such an array, we'll need 2 loops instead of 1. So but as we haven't got any data in this, let us first add some data to this array. So we can initialize independent rows separately. We can say AR of 0, which itself now is an array. So we'll say initialize it, new int, and then populate it with values. So 1 2 3. Then we can say AR of 1 is equal to new int, and then the value assignment 3 4 5. Similarly we can say AR of 2 new int 6 7 8, and we can say AR of 3. The last row will be 1 less than the number of rows, so new int. So this we have done to populate the data in the array. We have 4 rows and every row has 3 columns. So now we need a loop to print out the entire array. So I'll just have first one loop to go through all the rows of this loop. Now to understand how we print a loop, let us declare a loop not statically but dynamically, so that we have a better view of how things are working. So I'll just take this off and declare a two-dimensional array in a dynamic way. So now we see how we take a multiple dimensional array. Now in a one-dimensional array, every member of this array was a single value. So we say this is a one dimension. Now in case every member in this array is itself an array, suppose we say 1 2 3, this is one part, 4 5 6 another part, then we have 7 8 9 another part. So we have three parts in this array. This is the main array. So this is the main array, and it has all members which are themselves an array. So this has one member array, another member array, and another member array. So AR in itself has three one-dimensional arrays as members. So because now this array does not have single values as member, rather it has arrays as members, so this is a two-dimensional. Now in case this part again has members as arrays, suppose like this, then we can say this is three-dimensional, and so on. So every member of the array, in case that is an array, we say it is a two-dimensional. Then their subsequent members, they become arrays, then we say it is a three-dimensional. So we'll just take two-dimensional and try to print on the array. So this is a two-dimensional array. One bracket. Now what in this case shall be AR dot length. Now AR dot length means how many members are there in this array. It starts from here and which is ending here. So it has one member, it has a second member, and it has third member. So AR dot length will be 3. So I hope this clears what exactly is the length of the main array. It is 3 because it has 3 member arrays as constituents. Every member itself also has a length of 3, as we can say AR 0 dot length, this is also 3, AR 1 dot length, this is also 3, AR 2 dot length, which is also 3. Now this member is AR 0, this member is AR 1, this member is AR 2. So we'll just put down a loop. We'll say int I equal to 0, I less than AR dot length plus plus I. So what exactly we have done with the I loop is we are picking up one member at a time, and then we have to use another loop to move through this loop and print every value. So we'll take another j loop for int j equal to 0, j less than AR of I dot length plus plus j. So let us see what we have done here is, now when in every iteration of the I loop we pick up a member of this, and through the j loop we iterate through that member. As first we have I equal to 0, we have AR 0 dot length, so we'll be browsing through the AR 0 member, and we can print here AR of I and j. Now what I'll do is I'll print this array in this format. So instead of println, I'll take print here and put some tab so that there's a space between values, and then after every row I'll put a println. I'll just remove this, we're not needing. So for after every row that we print, we'll then shift on to a new row. So just see the output for this. We'll just comment this because we have already directly initialized all the values. So we have 1 2 3 4 5 6 7 8 9. So just see the output. This is 1 2 3 4 5 6 7 9 9. This is AR of 0, this is AR of 1, this is AR of 2. So this is the way we print a two-dimensional array, where in the I loop we select one part of this, and then in the J we select every part of this. So very similar to this, let us see how the for each loop works to print a multi-dimensional array. So we'll say for int, I'll say A in AR, another loop for int B in this A, then again print B plus tab, so I'll just comment this loop and see the output from for each loop. So what exactly we have done is, every iteration of this loop will take a member from this, and since every member of this is itself a one-dimensional array, so we have created a variable of type one-dimensional array. So this will store this in A, and then we'll iterate through every member of A through a variable called B. So this will put in every iteration a value from A into B, just as we did for a one dimensional. So this essentially is what we did for a one dimensional loop, and this is picking up every member of this array like this and storing this into variable A. So we'll again see the output, which is exactly same as we had got earlier. Oh, sorry, I have mentioned println. Just remove this. So the output is exactly same as we had for a simple for loop, except that this is a for each loop. So this is the way we can use a for each loop to print an array, and this is a multi-dimensional, two for loops for printing a multi-dimensional array. Now another point to common mistake that we make is that the scope of a variable we need to keep a check on, that this for loop of j is from this bracket to this bracket, so we can use j only within this period. In case we refer to j in any scope that is beyond this for loop, then there is an array, whereas the scope of I ranges from this point to this point, so we can refer to I anywhere within the shaded portion, whereas for j the scope lies between this portion. So here referring to j generates an error, so we must keep in mind while using I and j within multi for loops that they don't violate the scope of a variable. So this is how we dynamically create an array. Now we can even have different number of columns for every row. We can have 2 here, and then this is uneven kind of array where every row has different number of columns. So we can do either way. This is the output that it comes. We can have comment this. Let's see the output from one of the loops. So this is how we can create an uneven array. But how do we create such an array when we are statically declaring the array values? So we'll go back to the point 1 where we had declared statically a two-dimensional array. Now in this case what happens is, we altogether leave the number of columns. We are altogether left the number of columns that we have in this array, and then we'll have to initialize every row to tell it how many columns it should we'll say AR of 0 is equal to 1 2 3 4 5. So this is 5 columns. AR of 1, I'll say just 2 columns. AR of 2, we'll say it has 3 columns. Oh, not initialize the array. So we have 4 rows, so another row we need to add. Any number of columns you can take for any part. So we can manipulate the number of columns, but we cannot manipulate the number of rows. In case we have given 4, then we have to, and this number of rows cannot be changed once you create an array. So this will remain fixed, whereas the number of columns, that is manipulative. So even if we declare this as 3, even then we can change it. However, in case we want to decide at a later stage, we can altogether remove and declare the parts and give the length accordingly. So again we will try to print this array. So this is, so we'll just in a nutshell repeat what has been today's lecture. Now to declare a two-dimensional array statically, we have the type of the array, the reference to the array, the dimensions. In case it is 2 dimension, we need 2 square brackets, then the operator that assigns memory, then we have the rows, and this is the number of columns. So number of rows, in case we have equal columns, we can specify the column factor here. In case we are not sure about what shall be the number of columns in every row, we can altogether leave this and initialize every row of the array independently, and you can give any number of members, any number of columns that we say to every row. In case we want to dynamically declare any array, then we can, as it is 2-dimensional, so every member of this array shall be again an array. Closing. So this is the way we dynamically generate an array, and then we have seen that the length of this array is the number of members that this array holds, and that is 1 member, 2 member, 3 members. So the length of such an array is 3, and then individually this member goes to AR0, this is AR1, AR2, and accordingly for printing such an array you need 2 loops instead of 1, and for each loop you need to specify the type properly. As every member of this is an array, we take an array here, and every member of this single dimensional array is a single int value, so we accordingly denote this as a int. I hope this clears multi-dimensional arrays.